Phenology is the study of the timing of biological processes as they happen throughout the year. For instance, when do the crocuses bloom this year? Are they blooming on February 10th or March 20th? The warmth and the temperature of the different years affects the blooming. So if it's a warmer year, then the crocuses will bloom earlier than if it's a colder year. For instance, in the city where I'm living now, it's a really warm year, so the cherry blossoms are already blooming, but last year they were flowering a whole month later than they are this year. So that's phenology, which is the study of the timing of biological processes, and you can have flower bloom data, you can have when the trees leaf out, when the birds come in the spring, and when they leave in the fall. For this project, we're sonifying the phenology data from the lilac bloom data in Japan in the date range of 1999 to 2009. And as you can see on this map here, we have a map of Japan, and underlying that is a GIS database containing all the phenology data. We can then sonify that by placing fiducial markers on the map. For instance, I'll place a marker that represents a marimba sound, and we'll make a bounding box of the marimba between these two locations. So right now we can hear just a couple notes that are sounding, and that's because I've chosen a date range from 2000 to 2003. By rotating this other marker, we can change the date range. So now we can sonify all the data that's happening in the date range between 2000 and 2009. So you hear more notes that are happening as we rotate these markers. So now we're hearing all the notes that happen in that whole region. And the way we've sonified it is we have each year is represented by a pitch on the pentatonic scale. Earlier years are lower notes and later years are higher notes. So 2000 is the lowest note and 2009 is the highest note. If the flowers bloomed all on the same day every year, what you'd hear is all the notes playing simultaneously at once. However, if due to climate change, the climate was warming up and the lilacs were flowering earlier and earlier, you'd hear a descending glissando of notes going from the high notes down to the low notes. So right now we're sonifying this range of the map. We can change the bounding box by moving these markers around, which will allow us to sonify different regions on the map. We can then use other fiducial markers and place those on the map and sonify other regions. So we're using a marimba now, and I can sonify the data with a harpsichord as well for this other part of the map. So now we'll hear the sounds of marimba and harpsichord playing simultaneously. And this allows us to hear different ranges and explore the data. And this is a really important part of this project, is that we're trying to develop an interface to allow people to explore data sets and have a really nice intuitive way for them to see something physical and move around and explore data sets. Thank you very much. And this project again is called Sonophenology, which is sonifying phenology data. And this is in support of a paper for the International Conference on Auditory Display, or ICAD 2010. And my name is Stephen Ness, and I worked with Paul Reimer, Gabrielle Otowichuk, Norman Krell, George Xanatakis, and Andrew Sloss on this paper. You can check this out at sonophenology.snes.net. Thank you very much.